Welcome to all. This video is about we are going to do the data analysis by using R, but in this video we are going to work with hypothesis testing using in R. Okay, we are going to work with two tests here, t-test and ANOVA test. So there are two tests we are going to done here today. So if you want to do this, you have to know the library which is available in your RStudio. That's very important. Okay, the library, there are three libraries are essential for this practice. Library of deployer and library of ggplot2 and library of reader. So all of these three library available in my RStudio. If you face any error, you need to fix it, and then we can use this. Right now I'm going to load the data into my RStudio. Read CSV. This is the file name, right? It's there. So actually, where is this document section? So this is a file here. This is actually the file. Okay, this is a CSV file. So right now we are go with the data analysis. Okay, right. So first, to check it out, this is works or not. So, okay, first once I loaded here, it shows me that there are 1000 rows and 17 columns available. These are all the column specifications, so delimiters. It's there. Okay, check it out. Head of data. Right, so it works. So right now simply check the summary of it. Summary data to figure out the total, right? Yeah. So this is a summary. So minimum first quotient, median, mean, third quotient, maximum. Okay, if you are going to use a summary in blank, you will get general answer. If you want to use a summary for specific column, you can go with this. Okay, for example, summary of your gross income. Okay, so this is a summary of the gross income, just like that. So in this data set, there is any significant difference in a total purchase amount between the male and female customers. That is what we are going to discuss. Okay, male customers into the female customers. Okay, here you see that in this data set we have two kinds of genders, male customers and female customers. Right now we are going to analyze there is any significant difference in between based on those two customers in a purchase. Okay, so first for this we need to split this data set as a male and a female. Firstly, go with create a male data. Okay, this is your data set. Filter based on gender. Okay, you have a gender as a column, general, which equal to, we know there are only two available, so that's why we go with male. Okay, here you must type exactly like your data set. That's very important in this case, right? It works. Okay, So just if you want to see here, if you want to see this is works are just username, your name is entered here. Male, this is a number of male customers. Okay, so you have to use the same formula for female. So I copied it and pasted here, and right now split it perfectly. So this is actually to extract the total purchase value separated for male customers, store into the male, female customer store into the female name. Okay, so there are used for t-test comparison. So if you want to compare the t-test, you need at least two variables. So right now we are going to perform the t-test, t dot test. So simply this is a t-test, male female. So this is our variable name, right? Just this is the answer. This is the t-test answer. Okay, here you see that the mean of each the male mean, it's 310.7892. the female customers mean is 335. So what it means that the female customers spends more on average than male customers, but this difference must be statistically tested, which means check the p-value. Here is this a p check, you need to check the p-value. Here is a p-value. This is a 0.1181. what it means, it is compared with the significant level alpha 0.05. So this is actually greater than 0.05. So here what it means, so this is mean this fails to reject the null hypothesis. What it means, there is no statistically significant difference in average spending between male and female customer. If this is greater than if it is less than 0.05, then there is a significant difference both each other. And next one, confidence interval check. So here you see the percent confident interval check. So this is in between minus 54.799346 and to 6.19 6.18 6481. This is a confidence interval. So what is it? If the interval include the 0, it is not significant, but here the 0 is inside the interval. Okay, for example, in between the 0, it's inside. Okay, so which means that this is no significant difference in between each other of those two variables. So finally you come with the t value. It is a minus 1.5642. so this is a negative significant. So this is the negative sign. So what is a negative signs? This negative signs means the male mean is less than female mean. Okay, here you see that. So but magnitude is small, which means there is a weak differences here. So next, the degree of freedom, the df value, the degree of freedom value, what is it? 9997.34. this is a degree of freedom, which means that it is indicate that large sample size. So here we are uses the large number of samples. So while t-test uses in a unequal variance. Okay, so these are all the things. This is a t-test which is used here. And Right now go to the another one test, one way ANOVA test. So one way ANOVA test, we are going to check whether there is a significant difference in between the total sales across different cities. Okay, total sales, it is what is a significant difference in between total sales. Okay, here you see the total sales in between, the total sales in between across the different cities. Here, where is a city, customer city, here where is this, here's a city. Okay, here we are going to compare it to each other. Okay, first ANOVA test, right? Okay, summary of this. Okay, this is a ANOVA result summary. Okay, so right now we go with the so what is this actually the test? So this is ANOVA is checking is there is any significant difference in average total sales across different cities. Okay, so first we are going to check the null hypothesis. So all cities have a equal mean sales. Okay, so this is a all cities have a equal mean sales. So first the p-value here 4.413, the p-value, it's here. It is going to compare with the significance level alpha 0.05. so this is actually greater than 0.05. so what does it mean? Fail to reject null hypothesis. Fail to reject null hypothesis. So which means that there is no statistically significant difference in average sales across cities. So next comes to the F value. Okay, the F value here, the 0.885. So this is a F value. This is mean this is a very low F value. So it is indicate a small variance between groups. So which means all the cities there is no difference, which means the city differences are weak. So right now we are going to check the next test. So this is a post hoc test, which means a Tucky text test. So okay, so we are going to include with the ANOVA result into the Tucky text. Write it down. This is the answer for all this. Okay, so why the Tucky test is doing? It compares every pair of cities to each other. So here, for example, this is every single pair of the cities, and here this is actually uses into the p-value comparatively all these two together. In a previously we can see in this case the t-test p-value for two variants. So just like that, this is more in deep. Okay, comparatively those two together. Okay, for example, in this first one, this is not significant. So here this is also not significant. This is also not significant. Why this is not significant? All these values are more than 0.05. Okay, and so which means that no pair of cities shows a significant difference in sales. All this, there is no difference of sales there. Okay, right now here we are going to check it out, the confident interval check. Okay, so this is a confident interval level for the first one. So this is a minus 27.71 to 62.16391. So which means that if the interval include 0, if this in between, if the interval include 0, so all your there is no significant. Okay, if in this case this is an interval from here to there, the 0 appear. Okay, so it means that there is no significant difference. So all of these three cities, that there are 3 pair each other, there is no significant interval each other. Right now, next one, mean interval. So this is the mean interval of this. The first one plus 17.22. so this is mean that this is a slightly, so NAP, this city slightly higher than Manly, and right now here this city it's lower, the minus, which means that lower than Manly. This city's Yongpen is lower than the given city. So plus means the first one mean is higher. Here the minus means the plus one, the first one mean is lower. So but the differences are small and inconsistent, so not statistically meaningful of this, right? So there is another one test here, Shapiro test. What is this? This is a test for normality test for checking assumption checking. So right now we are going to check the data. We are going to take a total. Okay, so this is a Shapiro-Wilkie normality test. So this is it checks whether the data is normally distributed or not. So first we are going to check the hypothesis. First, the null hypothesis, the data is normally distributed. So alternative hypothesis, data is not normally distributed. Okay, so right now we are going to check it out. So the p-value, it is, so this is extremely small, very small value. So what is mean that the p-value it's a less than 0.05. so which is mean this is reject null hypothesis. So the data is not normally distributed, which means that the data is not normally distributed. Next, Wiki statistics, W, what is 0.90876. so this is the interpretation of W close to 1, which is normal. W far from 1, it is a not normal. So in this case, so this is near to 1, so this is confirm that non-normality. So the data does not follow the normal bell-shaped distribution. Okay, so this is it. So I hope you understand. So we can check it out, this this test into the another one column. Which column we are going to take it out? Yeah, we are going to check out the rating. Right here, this is also just like in a says previous one. So this is also here you see that this is reject all null hypothesis, because this is very too small of the p-value. This is very too small of the, it's extremely small of the p-value. So this is also reject a null hypothesis. Okay, and here this is also it's near to the 1, so the data does not follow the normal bell shape. Okay, right. So I hope you understand this video. If you have any doubt or any question, you can ask me. I will help you. Okay, see you.